beginning of class. Okay, so we're going to be doing some simplifying, reducing radicals. Okay, what's a radical? You probably, if I put an expression up there, you would probably say it's a square root. Well, that symbol is really a radical symbol, and any expression written with that radical symbol is called a radical. The radicand is what goes underneath the radical symbol. Now, why don't I just call it a square root symbol? Well, it's actually used for more than that, but let's talk about square root first. What's it mean if you're finding the square root of a number? If I put up here square root of 16, you probably would tell me that it's 4. Why is it 4? Okay, because 4 times 4, which could be written 4 squared, is 16. So identical numbers that multiplied to give you the radicand underneath there. So you're coming up with identical factors. Now, if we were using the radical symbol for more than a square root, we might be saying, what's the cubed root of 8? 2. Why is it 2? How many 2's? 3 this time. So we're raising to the 3rd power to get the radicand number instead of just to the 2nd power. So you can have to the 4th, let's see, 4th root of 81. What times itself? 4 times. This is where that factoring tree part that we did with the bell ringer would help. So if you did your 81 and factored 9 times 9, 3 times 3, 3 times 3, you would notice that there are 4 3's, which can help you figure out the 4th root of 81 is 3. 3 times 3 times 3 times 3, which is 3 to the 4th, is 81. So what we're going to be doing today is using the factoring tree to help us to break it down into prime factors and look for the right number of factors that are identical. If we're reducing something to the 4th, we want 4 identical factors. To the 3rd, we want 3 identical factors. We're going to focus on square roots today, so we're going to be looking for 2 identical factors in order to do some simplifying. So to find the square root, you're looking for identical factors that produce that radicand. So what does it mean by simplifying radicals or reducing radicals? What we're going to do is create a radical expression where the radicand, the number that's underneath the radical symbol, the radicand contains no perfect square factors other than 1. We're going to take out any perfect square factors. So what we're going to do is look for duplicate factors and get those factored out. If you have your bell ringer factorings, I know a lot of you did that on the iPad, so it's probably gone. Let's take the square root of 24 and simplify it. So if you don't have that factoring in front of you, quickly, I guess, reproduce it. 24 is what times what times what? 2 times 2 times 2? Times 3? Okay, so since we're factoring the 24, I'm going to put it under the radical. 2 times 2 times 2 times 3, and I can just check it by multiplying. 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay, so now we want to look for duplicate factors. So what do you see as duplicates? 2, okay? So 2 is a duplicate factor. So we're going to factor that 2 out in order to simplify. And then what's left underneath is still 2 times 3, so 6 when we put it back together. So we're going to take the square root of 24 and simplify it to 2 times the square root of 6. Now how do I know that's simplified? What the radicand, let's see what the square factors are. What are the factors of 6? 2 and 3. Is 2 a perfect square? Can you do the square root of it easily? No. Is 3 a perfect square? No. So we got rid of perfect square factors. What was the perfect square factor that was in 24? 6 and 4, so 4 was the perfect square factor. So if we were thinking square root of 4, square root of 6, the square root of 4 is where this 2 comes from, because it was the perfect squares factor. Now there is more than one way that I can teach this, but for those that have trouble coming up with factors and perfect square numbers specifically, this factoring tree method works for that. And also when you go to Algebra 2 and you have to the 3rd power or 4th power, you can apply this multiple factor idea to different roots, not just square roots. Let's try another one. Square root of 32. I think that's one that was on the bell ringer. Still got your factors maybe? Yeah, okay. So if you're looking for factors, your iPad's up right now. So on the desk. Okay, so 32, but you didn't get a factor. 32, what times what times what? How many 2's? And was that all? Okay, 2 times 2 times 2 times 2 times 2. Okay, so now we're looking for pairs. Well, there's a pair of 2's, so I'm going to have a 2 that's outside, but there's another pair of 2's. Another 2 goes outside. So I've paired up twice. And then I have an extra 2 that doesn't have a pair. So on the outside is a 4. So 4 times the square root of 2 is what 32 simplifies to be. If anyone wants to do the think of perfect square method, what did you have to think of this as? Square root of 16 times square root of 2. I know there was a square root of 4 in it, but if you're doing that method, you have to get the largest square root possible. All right, square root of, I think here's one you didn't do at all. Square root of 128. Okay, so they're telling me there's a lot of 2's. 7 of them? 2, 2. Okay, pairing them up. When you pair up, what goes outside of the radical? It's that number. Another way to think of it is when you pair that up, you're doing the square root of 2 times 2, which is 4. The square root of 4 is 2. So that's another way to think of it. Here's another pair. So what goes outside? Another 2. There's another pair. And then there's the lonely 2 that doesn't have anyone to hold hands and walk outside the square root with. So it has to stay. 2 times 2? 4 times 2? 8. So I should have 8 times the square root of 2. Who all got that right? I didn't get around to see everybody. Okay, question? There are a few that didn't quite get that. Okay, let's do one more of this type before I throw in the next thing. Let's go with square root of, where should I go? 135. Simplify. Square root of 135. Seven would be 3 times 9, that's 3 times 3. If you put the factors in order, it makes it easier to pair them up because the identical numbers are beside each other. So I've got 1, 2, 3 3's and then a 5. So what pairs up to go outside? Vanessa? 3. So the 3 goes out. but the 3 and the 5 have to stay. So we'll simply create 3 times the square root of 15. And how many got that one right? It looked like you got stuck kind of factoring to begin with. All right, so next thing I'll do is throw in some variables. Let's go square root of 100x squared. What would that simplify to be? I think 100 was on the bell ringer. Get your prime factoring. 2, 2, 5 and 5. Okay, that's the number. Now how do I factor x squared? X squared means what? X times x. Not x times 2, but x times x. So pairing up, there's a pair of 2's that will be able to go outside of the square root. There's a pair of 5's. There's a pair of x's. So what's that go outside as? X. There's nothing left for under the square root. This one was a perfect square. So we actually get 10x. I think 10x times 10x, 100x squared. So the variables, write it out with all of the separate variables then so that you can pair it up. Okay, let's try a similar one. 20x to the 5th. Square root of 20x to the 5th. You'll get the idea how it simplifies if you see it, and you can pair things up. So the 20 was 2 times 5, and then x times x times x times x times x. Okay, pairing up. There's a pair of 2's. There's a pair of x's. There's another pair of x's. And what doesn't have a pairing is a 5 and an x. Okay, so I put the things that did pair up and the things that didn't pair up. So I end up with 2x to the 2nd times the square root of 5x. Doesn't look too simplified, but remember the goal is to get what's underneath the radical to not have any more perfect square factors. Thumbs up or down? How are we doing? Making sense? Okay, looks like we're doing pretty good on that. All right. If there's more than one variable, then you're just going to have more than that, I guess. Let's do one more and then we'll move on to the next thing. Square root of 121ab to the 3rd. What times what is 121? 11 times 11, correct. So 11 times 11. And A, B, B, B. Ben, put it over here. The A doesnn't repeat. Just on my green. The A doesn't repeat. If it was repeating, it would be in the parentheses. So the A is there once, the B is there 3 times. So pairing up, 11, and underneath there's an A and a B that remains. So you could have more than one variable repeating or not repeating. It could have numbers both places, just depends what pairs up. All right, now where are we going to need to use this type of skill? We're going to be doing Pythagorean theorem quite a bit. We introduced the Pythagorean theorem in chapter 1. What is the Pythagorean theorem? A squared plus b squared equals c squared. Which part of that, A, B, or C, is the hypotenuse? C. And how do you know which one's the hypotenuse in the triangle?
Longest.
It is the longest, but if I can't visually figure out which is the longest, tell me more.
It's the one that doesn't
opposite the right angle, doesn't form the right angle. Okay, so over here is the C. Let's have you find C. Okay, I'm going to give you 5 and 10, but now I want you to simplify the answer, not give me a decimal. So do what we're doing at the end of the problem. Okay, so start with your Pythagorean theorem. What squared plus what squared equals what squared? 5 squared plus 10 squared equals C squared. 5 squared, 25. 10 squared, 100. So that's 125 equals C squared. Now I want just C. So what's the reverse of squaring something? Square rooting it. Right, so technically you're square rooting each side. In Algebra 2, we'll concentrate on that it's positive and negative, but because we're looking for just a length, the negative's not going to make sense anyway, so I'm going to kind of skip that for the moment. So square root of C squared, that's C. Square root of 125, 15. 15 times 15, I think that's 225.
11 times 11 is 121.
Reduce, not estimate. I would agree it's 11 point something, but I don't want a decimal. I want the exact reduced answer. Okay, 5 times 25, and that's 5 times 5. So 3 5s. So I ran out of room. So C is the square root of 5 times 5 times 5. Pair it up. So C is 5 times the square root of 5. That's the exact value for C. Now, if you came up with 11 point something, that's a rounded approximation for it. Not the exact value. So we're going to use it in something like the Pythagorean theorem, trying to reduce it. Another place we will use it is in the distance formula. Write down the distance formula. We did that chapter 1. Which formula was it? Was it on the wall?
X.
No, the one you're saying, Kieran, is the slope formula.
Is it y2 minus y1 squared?
It's the top one. Yeah. The D equals, okay, write that formula down on your paper for yourself. That's the distance formula. It's a great big square root. We're not going to come up with a decimal answer. Well, if you'd like to try and plug it into your calculator for chapter 1, that's not what we're doing. We need to work it through so that we can simplify it in radicals. So that we have an exact value, not a rounded decimal value. Okay, so let's do a distance formula. Here are the 2 points. A is going to be the point -2, -5. B is the point -8, 1. I want you to find what AB is. So find the distance from point A to point B. What are your x1, y1, x2, y2? They're coordinates of the point. So you need to write your x1, y1, x2, y2. So you know what numbers to plug into your equation. I just thought of a mistake that a lot of you did when we did that. What's negative times negative? Positive. And if you're not writing it right with the parentheses around it so that you're squaring the negative, then you are doing something wrong. Because you should not be getting a negative at all as you go down through this. So square root of, let's see, did I put the x's first? Okay. So -8 minus -2 squared plus 1 minus -5 squared minus negative plus positive. So -8 plus 2 is -6, but we still have to square it. Now, a lot of you get lazy and you write it that way. That's incorrect. Because that means 6 times 6 and then the opposite of it. But we need to take -6 times -6. That's what's in the parentheses. So -6 times -6 is going to be positive 36 right there. And 6 squared is going to be another plus 36. Again, you get lazy and don't write the square root, and students then forget to give me the correct answer at the end. It's not 72, it's the square root of 72. What are we going to simplify that to be? Well, get your factoring done on 72. What times what? That formula's even where I have my numbers. So you are taking the x and the y on the first point, instead of the x and the x, the y and the y. Something similar? So probably a good thing, like to do apps on your iPad, look for an app that does integers. Calculating with integers, I know there's all kinds of like integer quizzes and things like that, just to practice your positives and your negatives. Add, multiply, divide, subtract. So operations with integers. I know that I have one written down that cost like 99 cents to do, but what are some other ones? Something like, oh, I don't have it. Integers Quiz Pro, I think was a free one. Integers Quiz Pro, that would probably do some various integer operations, but that would be a good use of your iPad. Okay, and you're reducing, let's see, had 2 times 2 times 2 times 3 times 3. So you paired up a 2 and a 3, but there was an extra 2 left over. So you should have 6 times the square root of 2 for the distance between those 2 points. Get it right? Okay, not as many hands. Did I not wait long enough? Or question on that one? Okay, we need to do another one. So let's scroll it down a little bit. Oh, that's interesting. Way up there. Okay, trying to just advance it. Extend page. Okay, another problem. Distance formula again. Here are your 2 points. C is the point 6, -2. D is the point 2, 8. I want you to figure out the distance between C and D in reduced radical. All right, are you ready for the answer on this one? I have 2 times the square root of 29. Yes? Got it? What was it the square root of? 116 to start with? So show of hands so I know how we're doing. Got it? Raise your hand so I know. Okay, now. All right, if you didn't get that number, first thing to check, and this is what I saw in some that I had to help already, 2 minus 6 squared, that would be your x2 minus your x1, and then add the y2 minus the y1 squared. I think the most common mistake is, oops, that's a 1, is putting the wrong things to subtract. Students like to subtract these two and subtract those two. That's not what the formula says you're supposed to be doing. Okay, so I've got negative 4 squared plus 10 squared, which is 16 plus 100. Square root of 116. If you get your factoring, it's 2, 2, and 29 on your factoring tree. So your pair, the 2 comes out, but the 29 isn't paired up. 2 times the square root of 29. So the distance formula, the Pythagorean theorem, and one that you used more in algebra, the quadratic formula. That's on the wall over here. Quadratic formula. There might have been a little song that your teacher told you or taught you in order to remember the quadratic formula. Which one I'm talking about? It's over here. This x equals the opposite of b plus and minus the square root of b squared minus 4ac over 2a. Oh, yeah, remember that. Okay. That's the quadratic formula. Write it down. I know some of you are running out of paper that I gave you. You might need to add your own paper now. It was, I'll write it up here. It was x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c, all over 2a. Now what that is for is to solve what's called quadratic equations. And a quadratic equation is going to be something that in general has the form something x squared plus bx plus c equals 0. That's the type of equation that we're going to be trying to solve. We have to pick out the a, the b, and the c from the equation we're trying to solve so that we can plug them into the equation to come up with the solution. So this will tell you what the values of x would be as a solution. But let's take a sample. Okay, the problem would say solve x squared plus 9x plus 14 equals 0. I'm going to give you them equal to 0 all the time for what we're doing, but I know in Algebra 1 or Algebra 2, it's not always going to say equal 0. But when it's in that form, notice it matches up with the green pattern. So what is the value of a? What's the number part here? 1. So a is 1. On the x part, the b is 9. And the c is 14. Now if there was a subtraction in front of any of those, it would be like a negative 9 or negative 14. All right, now to get the solutions, we just need to plug into the quadratic formula and simplify. So to get what x is, we take the opposite of the b value. Plus and minus means there's going to be 2 answers, one with adding, one with subtracting. Square root of 9 squared minus 4 times 1 times 14, all divided by 2 times 1. See where I got the numbers? Okay, so now we have to do some simplifying. Negative 9 plus and minus square root of 9 squared is 81. Minus 4 times 1 is just 4, times 14, 56, divided by 2, and it's the whole thing divided by 2, not just part of it. So don't get lazy writing it down. Okay, 81 minus 56, 25. Okay, so negative 9 plus and minus the square root of 25, divided by 2. Square root of 25, that's a nice number. 5. We don't really have to do the tree on that one probably and look for duplicates. You recognize it? So negative 9 plus and minus 5 divided by 2. Algebra 2, they're not going to give you perfect squares there all the time, but I think I did so that you can simplify. Okay, so now I'm ready to separate it. This plus minus means there's 2 answers. Negative 9 plus 5 divided by 2. and negative 9 minus 5 divided by 2. So this one ends up negative 2 and negative 7. Those are the two values for x. So what we did was solved it. We got x to be negative 2 or negative 7. So if I would take the time and go back and plug a 2 in here for x and calculate it through, it should equal 0. Or negative 2, sorry, negative 2. If I went through and put a negative 7 in for the x both places, it would calculate to be 0. So those are the solutions to the problem. All right, let's try another one. Your equation to start with, x squared plus 4x minus 5 equals 0. X squared plus 4x minus 5 equals 0. I want you to solve. Tell me what x would have to equal. It's a quadratic equation. Put it in the quadratic formula. Give you a perfect square number. So your answers, negative 4 plus 6. 1 and negative 5. Thumbs up or down? Okay, question? Okay, just something to be careful of. If I gave you a problem that had a negative b, just be careful how you get started. Okay, so I'm just making up a quick problem. We won't work this whole. X squared minus 3x minus 4 equals 0. What's the b value? Negative 3. B equals negative 3 is what I wanted to write. A equals 1, B is negative 3, C is negative 4. So when we go to this equation, yeah, it's going to end up being a positive in the beginning there. So x is going to be the opposite of negative 3, which is going to be positive 3 right there. And be careful when you do the square. Don't write it this way because that's not squaring the negative 3. square the whole b value. It should come out to be what? 3 plus and minus square root of, it's negative 3 squared, 9. Minus negative 16, and I'll kind of stop right there. But watch the signs on those so that you're getting things correct. Okay. All right, I have a worksheet for you. You want to do the quadratic formula ones first. They're the very last problems on the worksheet. So this worksheet is simplifying radicals, a few distance formula, and a few quadratic formula problems. We will, on Friday, take a short quiz on radicals. So simplify the expressions. Don't give me decimals, give me simplified square roots throughout the whole thing.